Hi folks, I'm going to take you through quiz 2.3 to 2.5, and hopefully you can use this to improve improve upon any of the mistakes you made prior to the unit exam. So I'll go through it relatively quickly, but if you have any questions about anything I did, please just send me an email and I'd be happy to respond and try to clarify things. All right, so the first one says evaluate, so that means we're going to take it all the way down to standard number form, but for all of these questions, let's remember BEDMAS, right? That's our order of operations. Brackets first, exponents, division and multiplication from left to right, and then addition, subtraction from left to right. So in this one, we've got an exponent, 5 squared, and then we've got additions. We have to do the exponent first. 5 squared is 25, plus 3 equals 28. Second one is very similar. So it's 5 squared is 25, minus 3 is 22. Third one, the exponent's on the second, so let's just, you just write it like this, 5 minus. Now remember, the exponent is only applying to what it's touching on the left here, so it's only touching the 3, it's not touching the negative, so it's 5, leave the negative, so it's 5 minus 3 squared is 9, 5 minus 9 is negative 4. This one we have brackets, so let's do the brackets first. 5 plus 3 is 8 squared, 8 squared equals 64. All right, on to question number 2. More of the same, also evaluate. Okay, some slightly different powers here. So we've got 4 to the 3 times 2, so we have to do 4 to the power of 3 first, so that's 4 times 4 times 4, and I believe that is 64 times 2 is 128. 4 times 2 to the power of 3 is 8, so that one should be 32. Okay, 4 times 2 in brackets. Now you can do this two ways. You can apply the power of 3 to 4, and then to 2 and then multiply, but I always do the brackets first. It makes it easier. So this is going to be 8, 4 times 2 to the power of 3, which is, I believe, 512. And this one, same thing. I'm going to do what's inside the brackets first. 4 divided by 2 is 2 to the power of 3, which is 8. Number 3, we're also evaluating just a few more brackets and things to worry about here. So we've got brackets. We have to do the brackets first, and then inside the brackets we've got an exponent that we've got to do first. So this is going to be 18. Divide by 3 to the power of 2 is 9 plus 1 minus 4 squared. Okay, so we can make this 16 right there if we want to, or we can just kind of take it left to right. Inside the brackets, we've got division and addition. So let's do the division first. That is 18 divided by 9 is 2, plus 1 is 3. So we've got 3 minus 16 is 4 squared. I feel like I made a mistake here somewhere. 2 plus 1, that's 2, 3. Oh, that's because this is to the power of 4. Yeah, that's what I forgot. Don't forget about the power of 4 there. So it's actually 3 to the power of 4. I guess I can write that in 2 steps. 3 to the power of 4 minus 16. 3 to the power of 4 is 81. Minus 16 should give you 65, I believe. All right, let's look at this one. We've got power, we've got division, we've got multiplication, and then we've got a bracket here. So let's just kind of do it one step at a time. 3 to the power of 3 divided by 9. Let's see what's inside the brackets first. 3 to the power of 0 is 1. So 1 minus 2 to the power of 2 is 4. So it's 1 minus 4 equals negative 3. 3 to the power of 3 is 27. And then we're going to divide that by 9. And we can do that first, or we can do that second. It doesn't really matter. Now we just go left to right. So 27 divided by 9 is 3. 27 divided by 9 is 3, and then times negative 3. Oh, I feel like I made a mistake here too. That's 1 minus 4 is negative 3. 9 is negative 27. 27. Did I make a mistake here? Huh. I feel like that's not the right answer. 3 to the power of 3. 3 times 3 is 9. Times 3 is 27. Divide by 9 times, we got to do the powers, so that's going to be 1. This is 1. And this is minus 2 to the power of 4. So 9 times 3 is negative 3. Yeah, so that should be 3 to the power of, left to right. So 27. And that's going to be divided by 9 times negative 3 is negative 27. So our answer is negative 1. Okay. Check on that. That's actually not right. Didn't have enough coffee today, I guess. Sorry, I've got 27 divided by 9 times what's in the brackets. I did what's in the brackets first. Then I did the exponent. 27 divided by 9 times -3 at the end. So 27 divided by 9 is going to be 3. And then we've got to multiply it by the -3 equals -9. Sorry about that. That took far too long. All right, more brackets here. Now, initially you might look inside the brackets and think, okay, I got to figure all this stuff out first, and normally you would, but if you look at it inside the big brackets, okay, everything inside the big brackets is to the power of 0. That's just 1 divided by, and then once again, everything inside the big brackets to the power of 0. Well, anything to the power of 0 is 1. So 1 divided by 1 is 1. So that's actually a really easy question. If you just recognize that the exponent is touching the bracket, therefore anything inside that bracket must be applied. All right, exponent laws 1. This one's mostly dealing with multiplication. Okay, and division. Okay, so when we have the same base, this is the most important thing with exponent laws. You have to have the same base. In this case, the base is 4, so it's really just 4, and then you add the exponents in the case of multiplication, so it's 3 plus 2. So the final answer is 4 to the power of 5. Now, it doesn't say evaluate, it just says write it as a single power. Well, that's your single power right there. Same for number 2, it's -2, and then you add the powers, so that would be 2 plus 4 is 6. And this one, when our base is -7, and then 0 plus 2 is 2. Same thing for number 2, except this time it's division instead of multiplication, so these ones you added them all, now you subtract the exponents. So same base again, same base, 8, so it's going to be 8 to the power of 7 minus 5 equals 8 to the power of 2, or 8 squared. This one's 10 divided by 10 to the power of 0. So the exponent here is 4 minus 0, so it's still going to be 10 to the power of 4. And over here, remember, fraction just means division, right? So we could keep the -9, put it in brackets because it started in brackets, and then 10 minus 5 is 5. Last questions, give myself a little more space here. Expresses a single power. So once again, we're not evaluating all the way down to a standard number. We are just, we are just taking it down to a power, and they've all got the same base here, right? So it's 2 to the power of 3 times 2 to the power of 6 divided by 2 to the power of 9. Just work left to right, okay? So we've got the same base, so it's going to be 2 to the power of 3, and then, because it's times 2, we have to add the exponent, so 3 plus 6 equals 9. And then divided by 2 to the power of 9. Well, that's 2, oh, sorry, that's 18, not 6. No, sorry, that's 9. 2 to the power of 9, 3 plus 6, and then 2 to the power of 9 as well. So 9 minus 9 is 0, so that's going to be 2 to the power of 0, which we know is 1. Okie dokie. What we got next here? We've got -5 to the power of 8. So there's a division and a multiplication, just work from left to right. So -5 is our base, okay? And then 8 minus 4 is 4, and then we've got to multiply that by -5 to the power of 3. So now we're doing multiplication. This one here, these questions are both add and subtract exponents. So we subtracted first because we had division first, and now we've got multiplication, so we add. So -5 in brackets, 4 plus 3 is 7. Over here we've got division. Now when we're dividing using a sort of fraction, numerator, denominator, don't forget that there's brackets that are implied on both the top, the numerator, and the bottom, the denominator. So just, I always write them in there, just keep it straight. So on the top, numerator, our base is 6 for both, so we can write 6, and then because it's multiplication, we add the exponents. Okay? And then on the bottom, it's 6 again, and we add the exponents again. This time it's 2 plus 4 equals 6. Now we still have division. There's still one more step, right? Fraction means division. So our final answer is going to be 6, and then 8 minus 6 is 2. So our final answer is 6 squared. This one is -5 to the power of 7. This one is 2 to the power of 0. Okay. Should be circling all of these as I go, just to say that this is the final answer. All right, next page. Now, more of the same. Still using the exponent laws for multiplication and division, but this time it says evaluate. So when we evaluate, we have to take it all the way down to the standard number. Okay, we've got subtraction, multiplication, and addition. We have to do the multiplication before we do the others. So I'm just going to write out 2 to the power of 2 minus, not going to touch anything yet. The 0 just applies to the 2. Anything to the power of 0 is 1. Okay. Sorry, I shouldn't do that. I should evaluate the powers properly. So this is minus, then we've got 2 to the 0 times 2. Well, 2 is just 2 to the power of 1. Okay, so it's going to be 2 is our base, and then 0 plus 1 is 1, and then plus 2 to the power of 3. Once we get to the point where it's subtraction and addition, we can no longer apply those power rules. Power rules only work for multiplication and division. So now we actually have to just evaluate these, get them down to standard numbers, and then just figure out what the answer is. So 2 to the power of 2 is 4. Okay, minus 2 to the power of 1 is 2, plus 2 to the power of 3 is 8. Okay, so we've got 4 minus 2 is 2, plus 8, and our final answer is 10. All right, next one. We've got negative 2 to the power of 6. We've got division there. We've got subtraction, and we've got division. So let's do the divisions first, and then worry about the subtraction last. So our base is negative 2. All right, so it's division up in this section. So let's do 6 minus 5 is 1. Let's just leave the minus there. And then we've got division again. So negative 2 is our base, and it's 5 minus 3 is 2. So once we're at the subtraction point here, we can't use the laws anymore, so we just have to evaluate this the way we normally would. So it's negative 2 to the power of 1, which is just negative 2, minus negative 2 to the power of 2. The 2 is touching, the exponent is touching the bracket, so the entire negative 2 needs to be squared, which is going to give us a 4. So negative 2 minus another 4, we're going more negative, is negative 6. Okay. Okie dokie. 4 to the power of 3, we've got division. We got to evaluate all these again. So it's division, and then addition, and then multiplication. So we're going to do the division first, then the multiplication. Our base is 4 for these first ones. So our base is 4, and it's division, so we're subtracting the exponents. 3 minus 2 is 1. Now, we can't actually do anything else with these other ones because they are not the same base. The base here is 2, the base here is 3, so we can't use those exponent laws. The base has to be the same. So this we just have to rewrite as 2 to the 4 times 3 to the 2. Now, because the bases are different and we've got addition, there's not much else we can do other than take it down to just the standard numbers. So that's 4 to the power of 1, plus 2 to the power of 4 is 16, times 3 to the power of 2 is 9. So that's going to be 4 plus 144 equals 148. We've got division here and addition. So we have the same base. Okay, we have the same base on the first one, so let's just write it as 3, and then 4 minus 3 is 1. Okay, then we've got the plus sign, and then we've got a numerator that's different than the denominator, so we can only work with the top side. I think that was 4 squared. I'll have to erase this little chunk there. Yeah, 4 squared. Okay, times 4 to the power of 0. Well, the base is 4 for both of these, and because it's multiplication, we add. So 2 plus 0 for the exponents equals 2, and then we have to write that second section, sorry, not the whole thing, that second section, over 2 to the power of 4. Okay, we can't do anything else with that because the bases are different. So let's just crank these out with numbers and see what we get. Standard form, 3 to the power of 1 is just 3, plus, okay, now we've got 4 to the power of 2, that's 16, over 2 to the power of 4, which is also 16. So what we're really asking here is 3 plus 1 equals 4. All right, next question. Exponent laws 2. Now we're dealing with powers of powers. So exponents basically on top of exponents. And always keep your BEDMAS in mind. Okay, it'll just make things easier for you. Okay, so let's write each expression as a product of powers or a quotient of powers. So it's asking us to write this as a multiplication of powers. Now, generally when we have questions like this, there's 2 different ways of doing it. When they ask you to write it as a product of powers, they want to continue to have the multiplication sign in there because that's what product means. Which means that the exponent has to apply to both of the things inside the brackets. So what you've got here is 3 to the power of 4 times 2, also to the power of 4. Okay, that's how you write it as a product of powers. There's a different way of doing them that I will show you later. All right, second question, same thing, right? We've got negative 4 in the brackets, and the 2 applies to everything inside the bracket, so negative 4 squared times 3 to the power of 2. This one here, we've got negative 12 and a negative 6, but they're both squared because they're both inside the brackets, so it's going to be negative 12 squared divided by negative 6 squared. And for this last one, remember fractions are just division. So up on top, it's 1 to the power of 6, and then on the bottom, it's 10 to the power of 6. And we don't have to evaluate those because it only asked us to show them as products of powers. Same thing with number 2. It just says write as a power. It doesn't say evaluate. So we've got 3 to the power of 4, and that whole thing is to the power of 2. Now, what this always means is when you got a power to a power, now you multiply the powers. So instead of 3 to the power of 4, it becomes 3 to the power of 4 times 2. 4 times 2 is 8. Okay, this one is 5 to the power of 0. And then that's all to the power of 3, so it's going to be 5 to the power of 0 times 3. Well, 0 times anything is 0. This one, the negative is outside the brackets, so make sure you keep that in mind. The power it's 7 to the power of 2, and then to the power of 2, so we multiply the exponents again, so it's negative 7 to the power of 4, 2 times 2. This one here, negative 3 to the power of 3 to the power of 2, so it can be written as negative 3 to the power of 3 times 2 is 6. Next one says simplify, then evaluate. So we're going to, now this is where I want to show you what I think is the quicker route of doing these. So up here, it asked us to write them as products of power. So product meaning multiplication, 3 to the 4 times 2 to the 4. If we're just going to evaluate them, there's a quicker way to do it, and it's BEDMAS. Okay, let's deal with what's in the brackets first, and then square it. It takes less time, in my opinion. You'll get the same answer both ways, but I think this is the quicker way. So when we're simplifying this, we've got 2 to the power of 3 times 2 to the power of 1 in brackets. Well, because it's multiplication, okay, this time we are going to add the exponents, right? Same base, 2. And then because it's multiplication with the same base, we can go 3 plus 1 is 4. And that whole thing is squared, okay? So now we've got a power to a power. We just solved for what was in the brackets. We've got a power to a power. So what we need to do is we need to multiply these two. So now we're left with 2 to the power of 4 times 2 is 8. And it says evaluate. So we've got to take that all the way down. And 2 to the power of 8 is going to be 256. Okay, we're going to do the same thing here. There's no brackets this time. So let's just set the power, and then divide at the very end, right? Because we're going to do our exponents first. So 10 squared to the power of 4. 10 to the power of 2, and then to the power of 4. We do what we've always been doing. We multiply. We add the exponents. So for the first part, the top part is 10. 2 times 4 is 8. And it says division, but I always like to write division as fractions. It just makes it easier for me to organize. The second part, the denominator, is going to be 10 to the power of 3 to the power of 2. So we multiply those again, still 10 as our base, and then 3 times 2 is 6. Once we've taken it down to this point, well, we know this is just division. So if we've got division with the same base, and it's 10, we just need to subtract the exponents. So it's 8 minus 6 is 2, and then to get our final answer, we should know by this point that 8 squared is 100. All right, the last couple questions are a little longer. Simplify, then evaluate. So we have to get it all the way down to standard form and get, an actual number answer without powers. In this first one, there's brackets and subtraction and brackets and everything to a power. So let's just kind of work this out and see what we can do. Now, these two, 3 squared and 4 to the power of 3, are not the same base. This one's got a 3, this one's got a 4. So we can't really do anything about that except take them down to numbers. And when taking them down to numbers, we're going to have to apply this squared to both. Okay? So we've got 3 to the power of 2 to the power of 2. So that's 3 to the power of 2 times 2 is 4. This is in the first bracket. Times. Then we've got 4 to the power of 3 to the power of 2. So that's 4 to the power of 3 times 2 is 6. So that's the first part. Minus, this one's a little easier because we've got 4 for both of our bases here. So let's just evaluate the middle part here before we apply the 2. So it's 4 to the power of 4 divided by 4 to the power of 2. So our base stays the same. It's 4. And then 4 minus 2 is 2. And don't forget the squared on the end. All right. So this is going to be, can't do anything else here because these bases are different. So I actually just have to take it down to the numbers. So 3 to the power of 4 is 81 times 4 to the power of 6 is 4,096. This is going to be a big number. Minus 4 to the power of 2 to the power of 2. Okay, so that's really just 4 to the power of 2 times 2 is 4. Okie doke. So let's just keep working with our numbers here. 81 times 4,096 is indeed a very big number. It is 331,776. Minus 4 to the power of 4 is 256, which leaves us with a final answer of 331,520. All right, so that's the A part. The B part, just looking the question over carefully, we've got brackets, we've got exponents, division, we've got brackets, we've got multiplication. Oh, and we've got another exponent. Now, so this is one of those ones where we can take the shortcut. The 0 is touching the bracket, so everything inside the bracket just becomes 1. So I'm just going to make a 1 there. So when I rewrite this out, I've got 2 to the power of 3 divided by 2 to the power of 2, all that to the power of 3, plus 1. Okay, so I didn't even have to figure out that second one because I know anything to the power of 0 is 1. We've got the same base here, so this should be pretty simple here. We've got 2, okay, to the 3 minus 2 is 1, and then that's to the 3 still, 1. 2 to the power of 1 to the power of 3, you got to multiply these, so you get 2 to the power of 3, because 1 times 3 is 3, plus 1, so that's 8 plus 1 equals 9. All right, if you have any questions, let me know, and good luck studying for your Unit 2 exam. There's a practice exam available, and I will also post my notes and a video on the practice exam to make sure that you have the answers so you can study for the exam. Have a good day.